I'm continuing with the Math 1113 Pre-Calculus Final Exam Review, and we're starting with question number 7, and it says solve 2 raised to the quantity negative 3 plus 4x equals 1/64. And so you have to remember that exponential and logarithmic functions of the same base are inverses of each other. And so since this particular equation involves a function with a base of 2, then I need to take the log base 2 of each side. So I'm going to do that. I'm going to say log base 2 of 2 to the negative 3 plus 4x equals log base 2 of 1/64. Now, you may not know off the top of your head, but I believe that 2 to the 6th is 64. So this really is log base 2 of 2 to the negative 3 plus 4x equals log base 2 of 1 over 2 to the 6th, or you can write it as log base 2 of 2 to the negative 3 plus 4x equals log base 2 of 2 to the negative 6. Now, the benefit of doing that is, again, remember that a logarithm and an exponential with the same base are inverses, and so they cancel one another off. So we would log base 2 and exponential base 2 cancel one another off. So you have negative 3 plus 4x equals, again, log base 2, exponential base 2, negative 6. And then I can solve, it's a basic equation, negative 3 plus 4x equals negative 6. I can add 3. Whoops, excuse me. Kind of jumped on me there. I'm going to add 3 to either side so that I have 4x equals negative 3. Then I need to divide both sides by 4. So ultimately, x is negative 3/4. And there's your answer. Question number 8 says, find all the zeros of the polynomial functions. Remember, the zeros are the same as the x-intercepts, so we let f of x, so we're really solving the equation 0 equals 4x to the 4th minus 3x squared minus x. And typically one of the first techniques we want to try when we're trying to find the zeros is to factor. And I noticed that in this particular problem, each piece has at least one x. So I'm going to be able to factor out an x as a common factor. I'm left with 4x cubed minus 3x minus 1. Then I don't really have a way to deal with this polynomial, the 4x to the 3rd minus 3x minus 1. That's a polynomial, and it doesn't factor. I don't have a technique for factoring it, so I'm going to need to use the rational root test or the rational zero test to come up with a list of possibilities. To create that list of possibilities, remember it's P over Q. P is the constant, which in this case is 1. Q is the leading coefficient, which in this problem is 4. So we would have plus or minus 1 over plus or minus 1 plus or minus 2 plus or minus 4, which gives us a list of plus or positive or negative 1, positive or negative 1/2. or positive or negative 1/4. Okay, now it's important, don't lose the x that we've already taken out. Okay, so one solution would be that x equals 0. So there's one of the zeros of our polynomial function, and I'm going to put a square around it. So there's answer number 1. Again, then to deal with the 4x cubed minus 4x minus 1, we've created this list, and then I'm going to do synthetic division. Now, you got to be extra careful here doing your synthetic division because you have 4x cubed. There's no x squared term. You have negative 3x and negative 1. Don't forget to add in that missing term. You cannot have a missing term when you are doing synthetic division. Then we just have to pick a number. From there, I'm going to start with 1 just because I don't want to have to do a fraction. So I drop the 4. 1 times 4 is 4. 0 plus 4 is 4. 1 times 4 is 4. Negative 3 plus 4 is positive 1. 1 times 1 is 1, which does give me a remainder of 0. Therefore, I now know that x equals 1 is a second solution to my polynomial function. And hopefully by now you know that since the high exponent is 4, we should have 4 answers. We could try, it's always good to see if you have multiplicity, so we should try the 1 again, but I don't believe it'll work, but let's try it anyways. Drop the 4. 1 times 4 is 4. 4 plus 4 is 8. 1 times 8 is 8, plus 1 is 9. Okay, it does not work a second time. So I'm going to go back and I'm going to focus on this line right here. This would be 4x squared plus 4x plus 1 equals 0. Now that particular polynomial might be factorable, or you could always do quadratic formula. I believe it will actually factor because you would have 2x times 2x, 1 times 1, which would then 2 and 2 would add to 4. So both are pluses and you equal 0. So then if you solve, once you get it factored and you solve that for x, notice that you have the same term. It occurs 2 times. Okay, so we would have 2x plus 1 equals 0. It actually occurs twice. I only really have to solve it one time, but I want to emphasize that it is occurring twice. So I've written it twice. Then I'm going to subtract 1 from either side. So I have 2x equals negative 1. Then I'm going to divide both sides by 2. So I have x equals negative 1/2. And that actually occurs 2 times. So your third solution is x equals negative 1/2 with multiplicity of 2, which actually gives us all 4 of our zeros. Again, the highest exponent tells me that I should have 4. So you have a 0 value at 0, you have a value at 1, and you have a value at 1/2 or negative 1/2, and it does have a multiplicity of 2. Question 9 is a logarithmic function. It says log base 3 of the quantity 7x minus 1 is equal to 3. Again, you have to remember that an exponential and a logarithm of the same base are inverses of each other. And so I have a logarithm of base 3, so I'm going to use the exponent base 3. So I'm going to have 3 raised to the log base 3 of 7x minus 1 equals 3 to the third. Recalling that an exponential and a log of the same base will cancel one another off. So exponential base 3, log base 3 cancel off. I have 7x minus 1 equals 3 cubed. 3 cubed, 3 times 3 is 9. 9 times 3 is 27. So I have a basic equation, 7x minus 1 equals, 7x minus 1 equals 27. I'm going to add 1 to either side. So I have 7x equals 28. I'm then going to divide both sides by 7. X equals 4. So there's my solution. Okay, that finishes the questions you'll see on the final exam that are related to the first half of the course, which is modules 1 through 4. And now we're going to pick up with information or questions that come from modules 5 through 8 and deal primarily with the trigonometry content of the course. So the first question, number 10, is to convert radians to degrees. Okay, so we start out and we have 5 pi divided by 9. I have to remember the relationship, and so you may want to make sure you have that written down where it's easily accessible. Again, the final exam is not proctored, so you'll be able to use your notes and that sort of thing. So we know that 1 pi is 180 degrees. And I set it up that way because remember, I'm trying to get rid of the radians or the pi. So now, because I have a pi in the numerator and a pi in the denominator, it divides out. 9 will also divide into 180 and give me 20. And so then 5 times 20, 5 times 20 would be 100 degrees. So 5 pi ninths is the same as 100 degrees. Number 11 is given a circle with a radius of 16 units. Find the length of the arc spanned by a central angle of 7 pi 6, and it wants you to estimate it using pi equals 3.14. Okay, this requires you, because you're looking for the arc, okay, you're looking for the arc, that's going to require that you remember a formula. There is a formula sheet for the final exam. I do not recall right off if that particular formula is on there. So again, you may want to have it where you can access it, but it is S, which is the arc length, equals R times theta. If you can't remember those symbols, this in words would be the arc length equals the radius times the central angle. Okay, so it's really just a plug and chug. They've given me the information. I'm just going to plug it into the formula. So S equals, it tells me that my radius is 16 units and that my central angle is 7 pi over 6. Okay, and I'm going to do that multiplication first, and then I'll put in the value for pi. Okay, so I can simplify this first. Remember, the 16 is over 1. 6 will divide by 2 and give me 3. 16 will divide by 2 and give me 8. And then I can multiply. 8 times 7 is 56 pi over 3. And then I have 56. Pi, we're approximating, is 3.1416 divided by 3. So you can type that into your calculator. Make sure you do the top first. So we have 56 times 3.1416, which would be 175 point 0.92.
Hello. Please leave a message after the tone.
9296 all over 3. And then I'm going to divide by 3. I apologize for the telephone interruption. It is 58.6432. Okay, in terms of pi. So this would be, really is in radians. Okay, so it's in radian measures. So we're in 58.6432 radians. Again, pay attention to how they ask you to round the final answer. Okay, and make sure you enter it correctly. All right, let's see if I can do one more. It says if the cotangent of theta is equal to 3 over 2 and theta is in quadrant 3, find sine theta. Okay, basically they're kind of asking you to do some manipulation of the various trig formulas, and you will be given those trig formulas on the test. Okay, so but it helps to kind of get a picture of what's going on here. So here's your x and here's your y, and it tells us that the angle theta is in quadrant 3. So I'm going to draw an angle in quadrant 3. Okay, so this would be like my theta. And theta, okay, so I'm going to kind of sketch in a right triangle. The other thing that I know that they tell me is that the cotangent of theta is 3 over 2. Okay, remember the cotangent is cosine theta over sine theta, and the cosine corresponds to the x coordinate and the sine corresponds to the y. So you really have, what they've given you here is your x coordinate and your y coordinate. Now because I'm in quadrant 3, I would have gone left 3, so that's -3, and then down 2. So I have both legs of my right triangle. I need to find the hypotenuse. I find the hypotenuse by using Pythagorean theorem, which is, typically we say a squared plus b squared equals c squared. So I would have the -3, which is one of the legs, plus -2, which is the other leg, and that equals the hypotenuse squared. -3 squared is 9, plus -2 squared is 4. 9 plus 4 is 13. And then you need to take the square root of both sides because we only want c. Okay, it is representing a distance, so it should be positive. So my hypotenuse is the square root of 13. So it's a lot of kind of prep work here because we haven't really answered the question yet, because the question really is to find sine theta. Well, remember, sine of theta is the opposite over the hypotenuse. So we would have the opposite of the angle, which is -2, over the hypotenuse, which is square root 13. And I'm not quite home free yet because remember, you have to rationalize the denominator. You cannot have a radical in the denominator. So I've got to multiply the numerator and the denominator by the square root of 13 so that I end up with -2 times the square root of 13 all over 13. So ultimately, this is my answer. The sine of theta is -2 times the square root of 13 over 13. Okay, again, it's a lot of steps, and so you got to get through in order to find the answer, and you're simply manipulating the formulas for sine, cosine, tangent, cotangent, and so forth.